All right, folks. Welcome back. Happy Monday. Good job finding the video, obviously. Glad you found it. Basically, I want to take this opportunity. It's not going to be a long video here. Since we kind of missed class on Friday and we missed a day the other day because of Schoology issues, I think that was Wednesday. I wanted to take this opportunity to go over a few things with you guys. Remind you how to do this factoring. You're going to do a pretty about 5 questions. I'd say that's relatively short because a bunch of them are multiple choice on just this type of problem. If you didn't have this equals 0, so let me scribble that out for a second. If it just without that equal sign and that 0, you're just looking to factor, and I'll review that in a second. But the activity you're going to do after this video is going to be this without the equal 0. But in order to keep us moving a little bit, I wanted to just go over a couple examples with the equal 0. It's almost exactly the same as, actually it is exactly the same as how you would typically factor without the equal 0. There's just the extra step of actually solving the equation. Okay, so this is kind of combining two skills. If you remember a section ago, we were solving equations and we had to factor out a term, a greatest common factor, then we could solve. This is like that, except for we can't just factor out a greatest common factor. We're going to have to factor out the whole thing. We're going to have to factor using the new method that we know. So here we go. It says equals 0. As soon as you see that there's two x terms in an equation being equals a number, as soon as you see that, you should realize there's going to be an issue here. Okay, we can't solve this. We can't start solving right away, subtract the 21 and go from there, because there's two x's and they don't combine into one x, so we're stuck. Okay, so as soon as you see an equation, if you see more than one x that you can't combine, think factoring. Okay, so before, when we had this, we could take a greatest common factor out. There's definitely not that. And by greatest common factor, just think, is there a number we could divide 1, 10, and 21 by? The only number that works here is 1, and dividing by 1 does nothing, doesn't change a thing. So no GCF. All right, and so just factor this like we did last week. Okay, 3 terms, x squared. And so that's your key to go like this. 3 terms, x squared is your biggest exponent. You're going to factor like this. 2 sets of parentheses. All right. We'll keep the equals 0 here. We know it's going to be x and x, because x times x is x squared out front. Okay. Remember, our numbers are going to multiply to 21. You can certainly do this as well. Remember, I think I showed you guys this the other day. Just make sure I would add these symbols here just so you remember that whatever numbers you pick here and here are going to add to negative 10. Sorry, I missed the negative. Hold on. That's my fault. Sorry about that, everybody. There you go. Negative 10 and multiply to 21. Now, in order to figure out the signs, start with 21. Think of some factors of 21. So, for example, 1 times 21. 2, 3 times 7. Don't think there's much else. 4, 5, 6. No. Those are the only 2 options. Now, right away, you should see 3 and 7 would get you to 10 somehow, right? But it's a negative 10. And so we got to think about, what are we going to do with 3 and 7? That has to be it. 1 and 21, you're not going to get anywhere close. Even if you subtract, you add, not going to happen, right? It's got to be 3 and 7. Now, they multiply to a positive, so they could both be positive, but if we add these, it'd be positive 10, so not going to work. But what if we negative, negative? Negative times a negative is positive, so it works here. And negative 7 plus negative 3 is negative 10. There you go. So negative 7 and -3. Okay, so if we didn't have this equals 0, I'll erase it for a second, we'd be done. That's factoring right there. Okay, that's what you do. Two sets of parentheses, x and x. Oops, still had the eraser picked. My bad. X and x. And then think two numbers that multiply to 21, add to -10. You might have to play around with it. You can definitely make this x down here like this. Or you can do what I kind of do, which is just kind of come off to the side and think, oh, what are some factors of 21? Go like this, and then just play around with the signs from there. Okay. Now, when there's an equal sign, now the assignment you're going to do right after this, you're done. This would be it. You're done. But because there's that equals 0, you would solve this just like we did from the section prior to this. And that is take each piece and set it equal to 0 and solve it. Does that make sense? So x equals 7. I'm not even going to do that. It's adding 7, adding 3. Okay? So if you have an equal sign, you're going to have to do this. Okay? If you don't, which you're not going to in the assignment for today, I just wanted to give you an idea of what this looks like and, review factoring. If you don't have the equal sign, you're just going to do this and you'd be done right here. Okay? Let's do one more example just to take a look at it. All right, actually, let's do this one. Okay? One more, and I'll let you guys work. All right? So again, ignore the equals 0 for now. We know it's an equals 0. We see the equation we will have to solve, and we can't solve it like this. Two n's, one's squared, one's not. We can't combine them, so we're kind of stuck. Think about factoring. All right? Again, no greatest common factor. The other way you can tell, you can use the numbers 1, 1, and 42. There's no greatest common factor there. And there's no n here. So it's not like we could even pull the letter n out of each of these three terms. Okay? So no greatest common factor. So let's jump to factoring the way that we learned how to do. All right? N squared, n times n. So it's going to add to -1 and multiply to -42. So I'm going to bring that -42 over. And for now, let's just think of factors of 42. 1 times 42, 2 times 21, 3 times, what is that? I'm going to grab my calculator here. Sorry about that, everybody. I just don't know that one off the top of my head. 42 divided by 3. 14. See if I can get my pen to work. There we go. 14. 4 doesn't work. 5 doesn't work. 6 and 7 do, though. Okay. So there are some factors of 42. Okay. The multiplication, if you notice, is always the last thing, right? Okay. So multiply to 42. Now it's -42. So one of these has to be negative, either the bigger number or the smaller number. Okay. But look what it adds to. It adds to a negative. So the bigger number. So when I say adds to a negative, I'm talking right here. Adds to a negative. It's the sign out in front. It's a negative. Okay. So it adds to a negative. So the bigger number is going to have to get the negative. So I'll put the negative on the bigger number there. Okay. And then just you can grab a calculator and add these and just kind of cancel as you go. 1 and 42 definitely, 1 and -42 definitely not going to add to -1. 2 and -21 still too far. Still too far. It's got to be this one. You can grab a calculator. You can see the difference between 6 and 7 is 1. So it's got to be that one. Okay, so we're going to put +6, -7. So we're all done factoring. And like I said, if we didn't have the equals 0 here, we'd be done. We have the equals 0, and you guys know how to solve this type of problem. Set each piece, and this is the zero product property, where if you have two things being multiplied, which is this, and they equal 0, one of them or both of them could be 0, so find what makes them 0. All right. n equals -6, n equals 7, you're done. So the equal only creates one extra step. So you're not going to have to do that. You're going to go here. Oh, let me close that. You're going to go into this assignment, and you're going to do these questions. They do not have equals 0. All I want you to do is just work on factoring. You can see, look, no equals 0 for any of them, okay? Just factor, and you're done. Tomorrow, we'll factor, and we will do the equals 0 part, all right? So, ladies and gentlemen, take care. Have a great day. Thank you for watching this, and get that assignment done.